When you introduce parallel or asynchronous operations, you often may have tasks that create other asynchronous operations as well. These nested tasks are also known as child tasks, and the task they originate from is known as the parent. We've got ways to configure how these child tasks operate, and in order to do that, we cannot use task.run. I've created a new console application. Let's have a look at how we can configure how the tasks operate. Task.run don't have an overload that allows to configure what's known as the task creation options. In fact, task.run is simply a shortcut of using the task factory and starting a new task through that. The task factory allows for a whole lot more options to be specified. Let's use the start new method on the task factory. Again, this is what task.run uses internally. Start new have a lot more options that can be set. It allows us to pass the action that will run asynchronously, as well as the cancellation token. We can then also set the task creation options. We could also pass a value that will be sent into the task, which would avoid closures. If we'd like to mimic what task.run does, these are the default values it uses. By default, the cancellation token is set to none unless we pass a cancellation token. Then it specifies the task creation options. For these options, there are multiple different ones. The default for task.run is deny child attach. This means that tasks spawned inside our task cannot attach themselves to the parent. We'll have a look at what that means in just a moment. The final parameter is setting the task scheduler to the default scheduler, which is simply going to use the thread pool to queue the work. Using task.run is in most situations the right way to go, but this provides a little bit more flexibility. It's only supposed to be used for more complex and advanced scenarios. In most cases, you'll be better off using task.run. Just calling task.factory.startNew will simply queue an operation on the thread pool. Now we'd like to configure the task creation options to specify how to treat child and parent tasks. Before we do that, let's print something before and after the asynchronous operation. As you see, I can use the async and await keywords in console applications as well. You've been able to do this since C# 7.1. This is where they introduced the capability of the main method being marked as async. This asynchronous operation that we are starting using task.factory.startNew will start even more tasks inside of it. Then we want to be able to configure how they operate and relate to the parent task. The asynchronous operation will be creating 3 additional asynchronous operations inside of it, which will all just be simulating some work and then printing a message. Notice that we're not awaiting these operations. By now, you should be familiar with what happens when we execute the application. First, it will say that it's starting, then immediately say that it's completed. After it's completing, 1, 2, and 3 pretty much completes at the same time. Given everything we've learned throughout this course, this makes a lot of sense. It will immediately schedule the work for each nested task that the parent task creates. The parent task is marked as completed as soon as it started all of its nested tasks. Let's change the behavior of how the parent task treats the child tasks. We can configure that we want to attach each child to the parent task. This very long documentation is stating that by default, the child task, also known as the inner task, created by the parent, also known as the outer task, executes independently of its parent. You can use the option attach to parent so that the parent and child tasks are synchronized. Although the documentation is also stating that if the parent task is configured with deny child attach, setting this option has no effect. Deny child attach is a default value for task.run, which means that nested tasks cannot attach themselves to the parent when using task.run. This means the child tasks would then work as detached tasks. If we just attach the first one and run the application, the output is a little bit different. First, it says starting. Before printing completed, it will say that the attached task completed, which is a different behavior from before. Finally, the rest of the tasks complete. It didn't run the continuation until the attached child was completed, because the parent and one of the child tasks are now synchronized. Let's now attach all of the nested tasks in the operation. With that being changed, the continuation that states that the operation completed should now only execute once all of the nested tasks completes. And this is exactly what the application is doing. We didn't reach the continuation for the outer task until all of the attached child tasks were all done. This provides a lot of flexibility. If we were now to change the parent task to use deny child attach, we're back at the same behavior we had in the start, which means none of the child tasks were able to attach to the parent. Let's remove all of the task creation options and all the nested child tasks to explore another situations where creating a task with a task.factory.startNew is different from using task.run. We can introduce a new child task that simulates a little bit of load and then returns a value. If we'd like to await this child task inside the anonymous method before returning a value, we'd use the async and await keywords. Of course, this will generate a bit of code behind the scenes. That means that it might have a slight performance implication, but it's worth it because we can now await this call. We start an asynchronous operation using the task factory. It has an asynchronous anonymous method which awaits an asynchronous call. What do you think startNew will return? The return type is in fact task of t. If you await the task produced by startNew, this will give you the child task. You could then add another await to retrieve the value of that inner task. This is different from what you'd get if we change task.factory.startNew to task.run. If you do, the return type is instead task of t, and we can remove one of the await keywords. We saw earlier that calling task.run constructs the task using the task factory with a few default values. What it will also do is automatically unwrap. That means when we want to get the result of the operation, normally you just await the task produced by task.run. Let's change the code back to using task.factory.startNew. What's returned from the anonymous method is a task of string, because it's marked as async. Since we wrap this asynchronous operation, it totally makes sense that we'll end up with a task of string. So how come task.run provides a different type? It's because it's calling the method onWrap, which produces a proxy to give you a task of t instead of a task of t. When using task.run, you don't have to worry about this because it automatically unwraps. As we've discovered, the task factory allows for more configuration options. And in those situations, it's important to know how the task.run and the task.factory.startNew are totally different. When you unwrap the task, you no longer need the two awaits. If you need to specify the task creation options and use the task factory, you'll run into all of these situations that task.run solves for you. Another important feature of task.factory.startNew is that it provides a way to pass an object to the asynchronous methods without introducing a closure, which then avoids unnecessary allocations. Let's say that you create an instance of an object somewhere outside your asynchronous operation. You then want to use this inside your method body of that operation. If you simply point to that variable, that will introduce a closure, which generates code and possibly unnecessary allocations. To avoid this, there's an overload that we can use with the task factory. We can, in fact, pass an object to be used inside the action delegate. You'd have to specify now that the action expects a parameter passed to it. This would be of the type object, which means you'd have to cast it to the appropriate type before using it. This avoids unnecessary allocations by avoiding a closure. We've now explored how flexible the task factory is and that it's great for complex and advanced scenarios. You will, in most situations, be better off using task.run.